Okay, let's look at the quadratic functions, right? So a quadratic function is any function of the form, say f of x is equal to ax squared, a just a constant, plus bx, b is a constant, plus c, right? Then only condition on a would be a has to be non-zero. Because if it was 0, then that would be a linear function. So we would like to avoid that case. So a is a non-zero constant, ax squared plus bx plus c. Right? So example would be something like f of x is equal to negative 2x squared plus 3x minus 1, or something like that. Right? And this is called the standard form of a quadratic function. But this is not very convenient in terms of sketching the graph, because we cannot see the transformation very well. Right? And there's an alternative form called the vertex form, which goes something like this. F of x is equal to a times, all right, it's the same a, times quantity x minus h quantity squared plus k. All right, and this form is very convenient since we can see the transformation. So a is a combination of probably reflection about the x-axis and the vertical stretch or compression depending on the a value. And you can see that the minus h is going to shift right by h units, and the plus k is shift up by k units. Right? So the remark would be, in vertex form, transformations are visible. Right? So it's a very convenient form. All right, so let's look at some terminology of a quadratic function. All right, so let's look at the two separate cases when a is positive or a is negative. So leading coefficient a is positive, which means that there is no reflection involved. So the graph, which is going to be a parabola, is going to face up. All right, so you can see that this is going to be shifted to the right h unit and shifted up by k. So you can see that the vertex, the parabola, is going to look like this. Right? Because the original parabola is going to be right at the origin, which looks kind of like this. All right? Then you can see that it's shifted to the right by h unit and shifted up. Maybe I should draw an arrow here. So shifted to the right h units and shifted up by k units. So you end up getting a picture like that. All right. And the vertex is, in this case, is the lowest point of the parabola. In this case, just point h comma k. Right? Then axis is the vertical line through the vertex. So this is going to be called axis. Right? So equation is going to be x is equal to, right, h, which is just the x coordinate of the vertex. Right? And a maximum or minimum, there is no maximum because you can see that it's getting larger and larger forever, indefinitely. So there's going to be a minimum, right? Minimum value of this function is going to be at the vertex. So the smallest value is k. So k is the smallest function value. All right, the range is going to be the possible y values. So the smallest value is k, and looks like it's going to achieve any number bigger than or equal to k. So it's going to be start from k and everything above including k. So that's going to be the range. All right, and let's look at the other case where leading coefficient a is negative, which indicates that there's a reflection about the x-axis is involved. All right, so which means that the parabola is going to face down because of the reflection, and vertex is the same location, h comma k, so it's going to look like this. All right, then you can see the vertex. Vertex is exactly the same. It's going to be h comma k. All right, and the axis is going to be exactly the same as before, x equals h. All right, in this case, since the parabola is facing down, we can find the maximum, and there's no minimum, and maximum value is k. All right, the range is going to be, so the largest value is k, so it can achieve anything below or equal to k. So it's going to be from negative infinity all the way up to k. All right, since we want to include k, we're going to put a square bracket to indicate that the k is included. All right, so this is a quadratic function in standard form and a vertex form, and we went over some terminology such as vertex, axis, maximum, minimum, and the range of the quadratic function. All right, that's it. I hope that this was clear.